Well, hello everyone. I've just been listening to the other two presentations, and I'm going to switch the approach and the focus and the scale of what I'm talking about. And it's great to see so many people joining and from different countries. I know some of the Estonian students and anyone who was on the ELASA meeting in Estonia last summer will have visited one or two of the places that I'll be featuring in this talk. And when we're talking also about this idea of empty landscapes, quite often technogenic landscapes, or ones caused by mineral extraction and mining and quarrying, are often extremely empty landscapes. Often the existing landscape has been like emptied away and left empty places behind as well. But they also offer some interesting possibilities. So landform and land restoration is what I'm going to consider a bit from the point of view of planning and design. And I like to call this design by bulldozer, dynamite and excavator, which is very dramatic, because these landscapes can be very dramatic. And the tools that you use are very huge and very brutal in some ways, but also can do enormous changes to places for the better as well as for the worse. So when we're talking about what I mean by a technogenic landscape, it's one that's been created by technological activities, and particularly I'm talking about mineral extraction, different types of them which occur. And here's just a list: hard coal that's deep mined, hard coal that's been open cast or open pit or strip mined, brown coal, oil shale, deep mined or open cast mined, metal ores, fuller's earth, brick clay, ironstone, china clay, sand and gravel, hard rock and peat. And the ones in red are actually the ones that are mined in Estonia. So it has quite a bit of mineral extraction. And of the Baltic states and of this part of the world, actually it's the only place that has this oil shale, which actually provides most of the electricity and quite a lot of other products, chemical products and so on, in Estonia. So very briefly going through some examples of mining and the kind of empty landscapes that can be provided. So this is a deep mining of coal from the UK, creating a heap that's very simple, very bland, not very interesting, chemical problems. This is actually after the mining is finished, because the mine area itself is on the area to the other side of the heap itself. That's where the mine used to be, and you've got the mining village next to it. So big lumps of chemicals and stone sitting in an otherwise, in that case, agricultural landscape. Or it can be not a heap, but it can be a hole, and some of these holes are absolutely gigantic. Humongous coal mines, humongous iron ore mines, often in developing countries nowadays, in China, in South Africa, in India, where absolutely vast empty landscapes have been created, like we see here. Brown coal or lignite is still mined in Eastern Germany. It was the thing that was causing all the acid rain back in the 1980s, before this generally stopped. But again, absolutely colossal holes in the ground. Many of all of these holes end up filled with water, creating lakes, but incredibly deep lakes. And this is an aerial from a brown coal mine. And you can see from the scale of the fields and the villages and the roads how massive a space it is. And this kind of linear front, that's the place that's being excavated, kind of running back and forth, excavating off the face of this area. And in Estonia, the oil shale has been excavated by open methods. This is the mine called Aidu, which is now closed and has been restored in a way, and I'll talk about this later on. But very big areas in Estonia are modified in northeast Estonia by this oil shale. And that was what it looked like from the air. So it was started at the north and it worked its way to the south, and that was the southernmost edge of it. And as it was mined, it was restored by planting it with forest. So it's become this colossal area of planted forest, and what were roads that gradually descended in depth as the rock went downhill and the mine got deeper and deeper and deeper. They've now become canals as the water level rose, and they've been flooded, as I'll show you a little later on. And some of these from the heaps, from the deeper mining of the oil shale, are really empty landscapes. This is a heap called, a place called Tamiku near the town of Jõhvi, and it's an enormous heap of limestone rubble, which nothing grows on except maybe at one end, and it's just been abandoned since it was stopped being mined in the 1970s. It's just huge landscape. And then another type, which I'll come back to later on, is China clay, which is a really, really difficult material to work on because it's gooey, wet, slimy. And although that's a mine in Bulgaria, in Britain there have been several areas of China clay, which were a big challenge for restoration. And I'll show you a very inspiring project at the end. And then sand and gravel is something which there's been a lot of extraction of, because the Baltic states and parts of Finland are covered in gravel deposits from the glaciers and from the ice sheets and from the eskers and rivers running under the ice. So there's large areas of sand and gravel which can be extracted for road construction, for concrete, for cement and mortar and all of these kinds of things. And because often it's below the water table, you end up with lots of water and lakes left behind, which are quite attractive, and they naturalize very quickly. And also what we find is that there are some materials left behind. So this, for example, is at Kiviõli. The name in Estonian means rock oil. So the town is called Rock Oil or Shale Oil. And that's a heap of material that was partly burned, so semi-coke. So the oil shale was burned or heated to extract the oil and other chemicals, and then the blackened, half-burned remains were piled up into a heap. And so you've got these artificial hills dotting the landscape. Now some of them have been made into a ski hill and other uses. This one is actually being restored in part of it, but it's being built up on the right-hand side. It's still being built up as a hill by the current use of the oil shale from the factory. So we're left then often with undesigned landforms. Nobody's actually thought about what the land use would be after it's been excavated. Nowadays, yes, that is the case, but often in the past it isn't. And there are huge areas of old excavations and heaps which had no thought about what they could be used for. So we can play with them, and this can be a really amazing form of landscape design. I mean, you're really designing landscapes at a huge scale and designing landforms. And this can become an incredibly creative opportunity if you get the chance, working with bulldozers and dynamite and excavators and other big machinery. So it's rather cool, I think, to do that kind of work. Well, we can try and naturalize these landforms, make them look more like natural landforms. We can be more artistic and create new expressive forms. We could possibly leave what the engineers dumped behind as kind of monuments to industry and maybe revegetate them. And we can remodel those old heaps into something more interesting. Or, of course, in nowadays, we create the heaps as we go along, or the holes as we go along. So the end result is pre-planned. But in those older ones, then we have to go in there maybe with bulldozers and move them around. Now, there are very big challenges to these kinds of places. In fact, they're very much like those brown fields that Kati was talking about, except at a bigger scale. There are climatic or microclimatic challenges. Often you're creating a hill that's very exposed. There's no shelter on it. So you need to create some shelter, some topographic shelter to reduce the exposure to the wind. These are very, very windswept, exposed places. The water often just lands on them and then it runs off, and it often erodes. And sometimes that water is polluted with chemicals. So it's a good idea to provide channels for the runoff, to control it and to collect the water and to treat it and so on. You've got to think about what the use might be. Is it going to be for recreation? Is it going to be for motorbikes riding around it? Is it going to be for paintball games? Is it going to be for industry or housing? Is it going to be to make a nature reserve, or any of those things? Sometimes there are big practical problems. How do you get up those steep slopes to the top of those hills? They're often built at the natural angle of repose, so you can't actually make them any steeper, but they need to be shallower to be able to make paths or roads up to them. And if they're made out of rock and excavated materials from under the ground, what can we plant on them? How can we plant? Is there any soil? Can we make soil? Can we actually plant trees on them, or shrubs, or any vegetation at all that we can actually naturalize them? And some of these are incredibly challenging for that. So the landform design depends on what you can do. You know, if you've got more land around your heap that you can spread down an existing hill and make it lower and lower gradients, that's okay. Maybe you can't though. Maybe you have to work within the base of the heap because you can't expand it. You've got to just redesign the shape on that land. And you have these very practical things like the slope stability. Things might actually start falling down if they're too steep. And often that's why you can't grow anything on them, because it's too steep. The soil won't last there. The water runs straight off. And it's very, very dangerous if you start messing about with some of those kinds of places. So here's a not very wonderful picture of a sort of restored coal mine heap in Nottinghamshire in England, done very minimalistically. It's not very interesting at all. It's rather bland. Hasn't got much variation on it. It hasn't got any places for the water to find their natural channels. So it could be rather more interesting than that. At least it's been grassed over. And at a glance, you might think, oh, it's just a bit of a hill. But it's not really offering a lot of possibilities. And one of the problems we find with these is that they often have a flat top, because that's the way the machinery's left them, with these very steep slopes. And the engineers usually like to create things that are quite geometric. It's just in their minds. So you end up with a sort of geometric shape with very simple straight slopes and flat tops, and difficult to get onto and to use and make into anything very interesting. So one possibility is to create something that's rather more naturalistic. So you can look at the kind of landforms in the area and model it on those, creating some valleys, which mean the water can be managed, or you can walk up those, or you get sheltered valleys perhaps. And you've got more possibilities for vegetation, more possibilities for use, more interest for walking around them and so on. So if you look at them in angle or in profile, you could see the difference between the one at the top with a flat top and simple slopes, or the one at the bottom with more rounded shapes and varied gradients, and something that's looking a little bit more natural. Now, the other way is we could get into land art. We could actually start being much more creative. And you might have come across this kind of idea of creating art out of landscape, out of rocks, making different shapes, making different hills, modifying topography. And some quite famous artists have done this, such as Robert Smithson in this project called Spiral Jetty, which is clearly making a kind of embankment and artificial shape out into the sea with the spiral shape, which is part art and partly actually makes an interesting place to walk or to swim or something. And this is another one where the terrain was modified to create a kind of waving pattern. And you can imagine that if you're playing around with something that you're excavating, you could easily create something like that. Whether it's got a real use or not is a question, but definitely it's something quite artistic. Or this example, which is from Norway, where there's an artificial heap that's been created, and it kind of borrows on its silhouette or its shape the surrounding topography. It's therefore a bit of a mix of artistic creativity and also something a little bit more naturalistic. Well, one of the people who's been doing quite a lot of rather interesting artwork is the late Charles Jenks. And this is a very interesting earth sculpture in the grounds of the Museum of Modern Art in Edinburgh. So it's not actually a landform design after excavation, but I'll show you something that he has been working on. But when you see it in perspective, you can see it's got these rather interesting rhythmical, sweeping kinds of shapes. And it's expressing 3 dimensions in a kind of geometric way to some extent. And this could be made much bigger, of course, and we'll just model in a much larger scale to create something rather more interesting. And this is from a project near Newcastle in the north of England. It's a restored area, and you can see there are 3 cones that have been created with a small valley for collecting water. It's also a kind of suds pond type of a system as well. And it's associated with various places where they've been excavating coal open. And you can drive along there and you can see these. And of course, you can walk to the top of them and run down them and so on. And you can see the planting is in circular areas and so on. So somebody's been playing around with interesting shapes there. You could also go more figurative. And this is, again, a remodeling of a coal spoil heap in Scotland, where the local community, who were all originally from a mining village, so all the old people there, all the old men, they'd worked down the mine. And down the mine, when they were bringing the coal out, they used ponies to haul the coal trucks down underneath the ground. And then the ponies would come up for their holidays, as it were, and when they stopped working, they would be living in a field and having a retirement. And so they said, well, the pit ponies are, the pit is the old Ute word for a mine. And they said, well, let's design something like that. So they had a local artist who designed the 3D model of it, and then machinery came along and they created it and planted it. And people thought it was really cool. You can see it from the air. And it relates to the cultural heritage of the industrial heritage of the area and people's memories and people's attachment to the place, the kind of things that Katya was talking about. And then this is one of Charles Jenks's projects for a reconstruction of open cast mining of coal in the northeast of England. Some of you might have come across the famous sculpture called the Angel of the North, which is near Newcastle, actually near Gateshead, and it stands on a hill, and it's like a big steel structure of a person with their arms outstretched, which look like the wings of a plane. So this is the Lady of the North, or it's sometimes called Northumbria, Northumberlandia. And this is the idea of a reclining sort of Celtic goddess, actually made out of the material and constructed by bulldozers and tipper trucks and so on. And that's the design. And this is it under construction. And you can see at the top of the slide, there's the actual excavation of the coal. And then on this land, they've made this sculpture. And you can see the body is formed out of the black material, which is from under the ground. And then to the left of the body that's being formed is a pile of soil ready to put onto it afterwards. And this is how it looks. So it kind of looks like a woman, sort of, although I could say that parts of the female anatomy are not most exaggerated. But you can see this idea of the landforms, this spiral. It's almost like the spiral Jetty of Robert Smithson. The sweeping water features. You can tell it's Charles Jenks by some of these forms that he's incorporated there. And again, it's become a sort of talking point, a tourist attraction, something to walk around with lots of paths. And of course, it's quite new, so the planting hasn't fully developed there. So this is, yeah, people being very imaginative about how to create landforms, and you can play with them. Now let's think about this oil shale, because this has some very particular possibilities. Most of the shale heaps are formed actually from layers of limestone, because the oil shale is in a layer underneath a lot of limestone or in between limestone. So they had to take away all this limestone in order to get the oil shale out, and creating heaps out of it, which have these technical requirements, as all of them do, such as the slope angles and heights. But because you're using this large machinery, you can actually create whatever you want. But in the past, there hasn't been any real design. So this is one project. Well, it's not really a project. It was going to be a project, but this is a new heap. And this is a few years ago where they were building it. It's called the Estonia Mine, and it's near Jõhvi, and it's an underground mine. In fact, it's a small extension to an area where there is, in fact, the remains of the mining, when the whole thing is completed, will be 100 million tons. Enormous amount of material, and this is a small extension. And in fact, it's grown colossally. If I took that photograph today, the mine heap will be right in front of the camera, going upwards at quite a steep slope. Some of the students have been there and have seen it now. This is the same viewpoint that we stand and take the picture of at the entrance to the Estonia Kaevandus, and you can see it's grown a lot since then, and that's only in about 6 years. So what they do, of course, is dump the material off trucks, and of course it can be laid down at different places and different heights and so on, and that's what it generally kind of looks like. But if you were to move it around a bit, make it less steep, make it more rounded, and maybe add some material to it to be soil forming, not necessarily soil itself, but what could become soil after some time, with organic matter and nutrients and such like put into it, and more freely draining, then you could actually do something with it and plant over it. And there was actually a competition for that mine heap. And in fact, this goes back a few years, because Katja was actually studying with us and decided to take this course on Technogenic landscapes. And these were various options for designing this heap for ST Energia, as it was called then, or sorry, it was ST Põlevkivi then, but it's now ST Energia, ST Energy. And this is kind of interesting, because you can see it's a giant foot with toes, and the idea here was it was a kind of a joke on the idea of it being the ecological footprint of the mining. And the idea, yes, it was supposed to be a competition, but in the end, somehow it never happened, and it just got built according to a very simple engineering design, rather disappointing in the end. Now, the Aidu mine, which I'll talk about a bit further, was closed because they got to the depth where it became more economic to dig the remaining oil shale out underground. And so then they were thinking, well, what are we going to do with the material that we bring out? Let's do something with it. So some architects came up with this strange idea of building what appear to be Egyptian pyramids out of the material, and apparently trying to plant trees on something that's at a 30-degree angle of repose, which isn't going to be very practical, with wind turbines in the background. Well, actually, the wind turbines are being built right now, so it's becoming an energy park. But whether this actually turns into this sort of Indiana Jones and the Temple of Doom kind of landscape is anybody's guess. The open cast shale mines, they work in this progressive way, with a mine face advancing and restoration going in behind it, and the excavation is below the water table, so the water is pumped out, and then when the excavation is finished and the pumps are turned off, it floods. Little landform design had been worked. In fact, mostly it was being leveling it off as they went, and with a cliff face at the very end. This is the kind of machinery that used to be used. Unfortunately, it's all been taken away from IDO and scrapped. All you can see at one of the mining museums is one of these buckets. And this bucket, actually, you can stand a group of people inside, and that's what we often do, and take a picture. So this is a huge bucket. And this was an enormous machine used for excavating it. And you can see here, that's the area that was restored, and that's the final front being excavated. So it was dynamited, and then all the material that was blown up was moved by this machine. The limestone was put behind it, and the oil shale was dug out and then taken away. And that's the road leading down, and this is the area that was drained and now is becoming flooded. And this looks like what it is. So looking down through the layers, you have the forest, then you have some soil and glacial deposits, then limestone, then the oil shale at the bottom. So this was dug down, this was blasted, the forest was felled, of course, the soil and overburden was removed and dumped over here. Then it was drilled, it was blasted, the material from here was dumped behind, the oil shale excavated, and then this is restored and replanted. So you end up with this is advancing. That's the final cliff. The water is stop pumping, it floods, and then it becomes a lake with a cliff at one part and the forest up on that side. So this is what it looked like when it was operating. So this is the cliff. That's the oil shale at the very bottom. This is it being drilled. There's the drilling machine. And then they drill the holes. They fill it, actually not with dynamite, but with sodium nitrate fertilizer and diesel oil. And that's an explosive mixture that the terrorists like to use for car bombs and things. But they also use it in quarrying. And then it's exploded. And that's the material that is then dug out and moved back into this heap by the big machine that's out of view. And then it's the oil shale is removed. And then they move on to the next bit. So that's the actual practice. So this was the end point of the mine. And so that was everything that had been dug and replanted. And then what's being put into here, you'll see, is a rowing lake. It's shown as there, actually, but that's not quite the place. It's over here now, kind of here. And this is the roads that led down from normal ground level down to 30 meters below the ground level, which then flooded. So these are all channels that you can sail a boat on. You can come along the road and then you can go down there. And these are some big fields that were restored at one point. So this is the area, about 1,000 hectares. And so that's what you've got. This is where they dug down. You can see that's the oil shale at the bottom. That was the limestone that was replaced. And that's where they've got the oil shale was removed there. Then that's the limestone left in, and that's the land up above. That's the restored area, and that's the water, and that's the cliff face. The cliff is under the water. So that's how it was being looked at for the end product. And the view of it now. So this is one of those flooded roads. There's another one coming down there. This was all mined, those big fields. And then that is the rowing lake, which has to be seen to be believed. I don't have any photographs actually of it there, because for some reason I've been there lots of times but never taken my own pictures. But some of the students, I'm sure, have, and they've seen it and seen what it looks like. It's amazing, actually, if you have a chance to get there and look at it. But this is otherwise an empty landscape with wind turbines going into it. It's full of wildlife, actually, elk and bear and all sorts of things are living there. And then you drive down these bumpy roads through this area, and then you arrive at this rowing lake. And eventually there might be some developments take place there, some buildings and things. Sand and gravel quarries are the next kind of activity, and there's plenty of those. They're very flexible. You need to dig out as much for economic reasons. Sand, as you probably know, lies at a very low slope angle, but you can move and shape all this material extremely easily. And this is an area in the UK, quite an urban area, where they dug out areas and then left islands and bridges, and there's lots of fishing and sailing can take place on there. And these places revegetate themselves extremely quickly. You don't have to worry about trying to plant on them, unlike the oil shale areas. But once again, they often build them very uninterestingly. And the key thing with these is the shape of the water area underneath the water, the profile, because different depths of water determine what vegetation will grow there, whether it can grow in the water, on the edge of the water, if it can be emerging from the water. And if you've got very shallow areas, you can get big reed beds. And if it's very deep, you can't get any vegetation, it's open water. And if it's a very steep slope, then you don't get much vegetation at the edge. So by playing with the profiles, you can then basically predict what kind of vegetation will colonize and what kind of ecology you want to have there. So you can basically design the profile, and that predicts the eventual vegetation without having to plant it. And you can see this example here. You've got shallow areas, or much more shallow areas, with weed beds and an emergent vegetation and floating vegetation and open water. And then the trees and bushes that like to have their feet wet, like the willows, the salic species, and so on. And then the trees that like it drier in behind there. And this hasn't been restored. No planting took place here. This just did it by itself very, very quickly. Vegetation from in gravel works comes in very, very quickly. And a couple or 3 years after you've left it, it's basically already revegetated. And you can play around with this using models. So in the course that we run, it's an elective course, and some of the students listening have probably taken it. And we do projects where you make a model of what the water body would be like and how much you calculate. You start with sand, and then you work out how much you're going to remove from the area, so you know how economically your project has been, and then redesign the area and do the underwater design as much as the above water design in terms of the plan layout and the depths and the slopes and the shallow areas and deep areas. And all that, and you can create naturalistic designs, or you can create more artistic designs, or whatever you want to do, depending on your project. Now, one of the final things I wanted to show was a very inspiring project. Some of you maybe have heard about it, and if you haven't, then you should look it up. And if you ever go to the UK and you have a chance to go to Cornwall, which is quite a long way down the southwest of England, have a chance to go and visit it, because it is pretty amazing. So this was China clay, which is basically a kaolinite, which is created by chemical weathering of granite. So it's not clay in the same way you've got ground up stone that makes clay after the glaciers, for example. So it's a very strange chemical. It's excellent for making porcelain for China. But it's a really horrible material, and it was left and left and left for years and years and years, and people didn't know what to do with it. And then this guy came along and said, let's recreate something and do something really special here, and let's create an eco-center with tropical rainforests and all deserts and all sorts of things here. And people thought, what? But then they got all very exciting and created this fantastic thing. So the project came about. The slopes were restored to some extent, as far as they could be, with roads and car parking and planting areas and some lakes. And then at the bottom of the slopes, they build these gigantic eco-domes, which are made out of these geodesic forms, within which different ecosystems are recreated, like a tropical rainforest and a desert and a Mediterranean landscape and so on. And it's become a place to study ecology, and it's colossally valuable and busy for tourists to go there. It's a major tourist attraction in a place that was really quite a depressed industrial area, economically depressed. And this is what it looks like from above. So the whole of this area was basically this quarry, and it was like white horrible materials. You can see the access roads, the car parking, planting, buildings here and here, and then the eco-domes in through here. And yeah, it's a marvelous place. And then I just wanted to show you finally, this is actually what it looks like, just so you get an idea of the scale of it. You can see still there are slopes where the vegetation isn't growing terribly well because it's quite steep and it's difficult to deal with. So it takes quite a while to happen. And this is a view over it, again, with the same sort of background. And then this is it in the night time. So there are lots of things we can do and be very creative in these technogenic landscapes. And if you think landscape architecture is working on small parks and gardens and small areas, think again. You have the possibilities to work at these sorts of scales and to do something that's tremendously exciting and rewarding. So with that, I'll finish it, and thank you for listening.